Okay, so this is example 8.9, dealing with the traveling salesperson problem. And here we have a number of cities. We're starting from Boston, and we want to end up in Boston. And in the meantime, we have to make trips to Chicago, Dallas, Denver, Los Angeles, Miami, New York, Phoenix, Pittsburgh, San Francisco, and Seattle. So in case you're wondering, uh, these cities all have major league sports teams as well, which is part of where this came from. So the question is, how can I travel from Boston in a single loop, as it were, to each one of these cities without going to any city twice and end up back in Boston and minimize my travel distance? Well, this is a nonlinear problem. This is also a problem where we're going to introduce some discontinuities. So what we want to do is figure out the best route for the salesman to take. So what are the decision variables in this problem? Well, that may not be clear to you to begin with, so let me give you a hint. What does the salesman have to do first? He's in Boston. What is the first thing he has to do? He what? Well, he's starting in Boston, and then where does he do? He has to go somewhere else. Yeah, and it would make sense that you want to go to the closest city. I can understand that. But if you choose that solution, if you always go from the city that is closest to the one you're in, believe it or not, you don't end up with the best solution. But that's a good starting point, and that's probably what most people would do. Would be to start with the city that's closest to you and progressively move to cities that are then closer to the one you're at. But the point is, he has to decide where to travel to next. Wherever he travels to next, he's going to incur some mileage, right? So the decision variable really is going to be the route that he takes. So we're going to identify the route that the salesman takes, salesperson takes, as the decision variable. Now you notice we've given each one of these cities an index, and Boston is indexed at 0. It's indexed at 0 for two reasons. It's indexed at 0 because it's the starting point, and it's also the ending point. But more importantly, it's going to help us when we figure out the distances that we've traveled. Okay? So let me just start by creating a route. So here's my route. I'm just going to go to the cities in order: Chicago, Dallas, Denver, Los Angeles, Miami, New York. Clearly, I would not do this in reality, but that's okay because this is just my starting solution. Now, how do I determine the distance from Boston to Chicago? Well, there's no distance from Boston to Boston, obviously. The distance from Boston to Chicago, I can go to my distance matrix and look it up, and it's 983 miles. So how do I get 983 into my distance VLOOKUP? Okay, that will work as long as I'm looking up Chicago, right? Again, the VLOOKUP index has to be unique. So as long as Chicago is the first city I go to, I can do a VLOOKUP. But what if Chicago is not the first city I go to? I need a different way of figuring out my distances. And here is where a little Excel tool comes in handy. It's called index. And I think we talked about it a little bit at the beginning of the semester. If I use the index function, the way the index function works is it allows me to pick out a value from an array. All I have to know is the row and the column. Okay? Now look at the way this array is set up. The row and the columns are, well, it's what we would call an upper triangular or lower triangular matrix. In other words, row 1 and column 1, row 2 and column 2, row 3 and column 3, they're all the same, right? In other words, Dallas is in column 3 and Dallas is also in row 3. So let me go ahead and specify my array, which is, since I'm going to want to copy this down, I'm going to anchor that. And now what I want to do is I want to move from row number to column number. Okay? Well, what row did I start with to get to my ending point in Chicago? What city did I start with? Boston. What row is Boston in? It's in the first row. So if I go to my index, which is 0, and I add 1, I get row 1, correct? And what I also want to do is I want to go to the column where I ended up. The column where I ended up, what column is Chicago in? 2. So if I take my index and add 1 to that, I get column 2. In other words, I'm using this index and then I'm offsetting the index by 1 unit for the row and 1 unit for the column. And by doing that, I'm able to pick out the value for the mileage from Boston to Chicago, 983 miles. Now what about from Chicago to Dallas? Well, I'm going from, Chicago is in row 2, right? So I would go from index 1 plus 1 to get me row 2, and Dallas is in column 3, so I'd go index 2 plus 1 is 3. So the formula should work for Dallas. And to go from Chicago to Dallas is 1,205 miles. So if I copy this formula down, I get 1,205. Yes? If I reorder it? No, because it will always, the index, the city index will always be the same, right? Say if I went from Boston, okay, so suppose I went from Boston to pick a city, to Seattle, okay. So Seattle is 10. So I go from 0 to 10, right? I should get 2612 for the mileage. And I got 2612. So I go from 10 to 2, so from Seattle to Dallas. From Seattle to Dallas, 2404. There's 2404. All I'm doing is using the city index and then offsetting it by 1 to get the value in the distance matrix. Okay? So I can copy this all the way down now. And so the total distance I have traveled then is just the sum of each one of these mileages. And that is what? Total distance would be what? No, I'm okay. I know I'm going to Seattle twice, but I'm going to fix that when I do the solver. What is my total distance as far as this problem is concerned? What is it? My objective function, sure. Okay. All right. So if you prefer, I can go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay? That works too. No, 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 no. No, that's not the index for Chicago. This table is separate. Okay? Don't get confused by this table. This table is separate. All right? The route, this says I'm going from city 0 to city 10, from city 10 to 9, from 9 to 8, from 8 to 7, 7 to 6. Okay? The route is what's important to me here. The route that I take. The city's index numbers are invariant. They're what they are. But the route can be anything, right? I've got, well, how many different routes do I have? How would I calculate the number of routes? 10 factorial, yeah. It's 10 factorial. 10 times 9 times 8 times 7 times 6 times 5. Pretty big number, huh? So, all right. So, let's go into Solver and set this up. All right, so my objective function I want to minimize. And I want to minimize by changing my definition of the route that I take. Okay? Now, just like before, I'm going to set some bounds on my decision variables. So the first thing I'm going to say is that all of these values need to be integers. I don't think anybody's going to argue that. And then I'm also going to say all of these values have to be less than or equal to 10. And furthermore, they all have to be greater than or equal to 1. But there's a twist, right? The twist is I can't go to the same city twice. So I have to figure out a way to put a boundary on my decision variables so that if I choose to go to city 10 first, I scratch it off the list. So I'm going to add a new constraint or a new uh, boundary. Let's just call it a new bound to my decision variable. I'm going to say for all of these, they all have to be different. They're all different, meaning I can only choose a value once. That's a new one. We haven't used that one before. But in this case, it's pretty neat because this is going to keep us from going to the same city twice. So now, for evolutionary solver, just check my options just out of curiosity, see what I've got here. See, my mutation rate is back to 0.075, so I'm going to go back to 0.50. And I'm going to leave everything else the same. All right. And so now I'm going to click solve and see what I get. And pretty quickly it converged on 89.95. And I believe 89.95 is the correct minimum distance traveled for this solution. I'm just going to let it run for a little while just to see if it gets any better. I don't think it will. Just a little bit longer. Okay. So I'm over 20,000 problems and it hasn't found a better solution. So I'm going to stop it there. So there's my answer. I go from Boston to Miami, Miami to Dallas, Dallas to Phoenix, Phoenix to Los Angeles, Los Angeles to San Francisco. That's not a big surprise there. San Francisco to Seattle. Again, not a big surprise. Seattle to Denver, Denver to Chicago, Chicago to Pittsburgh, and Pittsburgh to New York, and then New York back to Boston. So geographically, that makes sense to me. I'm just doing kind of a big circle route around the United States. I go to every city once, and I minimize my total travel time, travel distance. What questions do you have? That's an interesting question. What if I went in the opposite direction? If I went 6, 8, 1, 3, let's see what that would work out to. So here, I'm going to just copy them over here for a second. All right, so 6, 8, 1, 3, 10, 9, 4, 7, 2, and 5. I would think, since we're going the same route, that I would get the same answer, right? One way I'm going clockwise, the other way I'm going counterclockwise. So I would think I would get the same answer. So copy, paste values, and sure enough, I do get the same answer. Would Solver try to force me to go the other direction, I wonder? I doubt it. Let's just see. Well, no, it's not. It can't, because why? Because it's already at the optimum, so it's not going to find a better solution. So it won't. I'd have to change one or more of, of the city solutions for it to. I'd have to go maybe 9, 10. Maybe if I did that, it might find a different solution. Now it got back to 89.95 pretty quickly, and it did it by swapping 10 and 9 back. So yeah, so it's going to be the same solution whether I go clockwise or counterclockwise. Yeah. How did the index function work? Okay, let's do it over here. All right, so if I do an index, it's asking me for an array value first. Okay, so in this case, I gave it the array value you see here. All right, so row 1 is Boston, row column 1 is Boston, row 2 is Chicago, column 2 is Chicago. All right, so when I say choose a row number, I gave Boston an index value of 0. All right, so that means I have to offset the index value by 1 to get the row that Boston is in, or to get the column that Boston is in. So I pick a +1 to get the row, and now the column, I want the column in this case that Miami is in, because I want 6, right? So I choose city 6, which is my, excuse me, which is, in this case, I'm sorry, that's New York, right? City 6 is New York. But New York is not in column 6, it's in column 1, 2, 3, 4, 5, 6, 7. So I have to offset it by 1 as well. So to go from New York to Boston, or Boston to New York, I have to go one row down, 1 column over from the index values. If you want to think of it this way, maybe this will help you. This is my index value 0, 0 in this cell right here. Okay? So that's where I start from. So to get to row 1 or column 1, I have to add 1 to each one of those values. All right. Well, Boston has an index value of 0. So basically I'm saying I'm starting from here. So to get to Boston, I have to go 1 down and 1 over. To get to Chicago, I have to go 2 down and 2 over. But I'm doing it from the index, which starts at 0, not at 1. So that's why I add 1 to offset. This is, you're going to see this again when we talk about Monte Carlo simulation, where 0 is a starting point. All right, and there's good reasons for doing that. I'm not going to go into them, but trust me when I say this, 0 is always a good starting point. All right? And so this problem just works better doing it that way. Now, could I have made Boston City 1 and made Seattle City 11? Sure, I could have done that. Then I wouldn't have to offset it. But since I'm starting and ending in Boston, I've got 10 cities to travel to, so it makes the problem nicer to read. Didn't have to do that, but I chose to do that. Okay. Other questions? If you were making out schedules for a sports team where you knew you had to play teams in different parts of the country, but you wanted to minimize your travel costs, you'd use something like this, wouldn't you? I would. So just, if any of you go to work for the Rockets or the Texans or, God forbid, the Astros, I kid. The Astros, I predict great things for them someday. All right.